to charge or power the laptop from the car 12-volt network. There are many similar converters in the internet. I selected, in my opinion, one of the best options. It's also probably agreed with the Chinese because this circuit they produce serially. Such models cost a couple of dollars and links to them are in the description. Why do something that can be bought for a couple of dollars? Many people ask such questions. I will answer simply. First, doing it yourself will be much faster than waiting for a parcel from China for 1 or 2 months. Secondly, there is nothing to compare with the joy that you feel of working of something that you created with your own hands. Plus, our design in appearance is no worse than Chinese one and even more compact. Let's consider the circuit and the principle of its operation. This is a single-step voltage regulator with short-circuit protection, so-called booster. The principle of operation is similar to the flyback converter, but the flyback's choke has a minimum of 2 windings and there is a galvanic isolation between them. The basis of the circuit is the most popular PWM controller from the family UC38. In this case, it is UC3843. For example, at the input of the circuit, we apply 12 volts and at the output we get 19, which are necessary for charging almost any laptop. In general, the range of input and output voltages is quite wide. By rotating the trimmer, it is easy to get other output voltages. I set slightly less than 18 volts since I need this converter for other purposes. The microcircuit generates rectangular pulses with a frequency of about 125 kHz. The signal goes to the gate of the transistor and it's working. When a transistor is open, some energy accumulates in the choke. And after this, when the transistor is closed, the choke gives off the stored energy. This phenomenon is called self-induction, which is characteristic of any inductive loads. It is important to note that the voltage of self-induction can exceed the supply voltage at times or even 10 times. It all depends on the inductance of a particular choke. A half-wave rectifier is straightening out the self-induction bursts in direct current, which accumulates in the output capacitors. The load is supplied by the energy stored in the capacitors. Such an inverter is very economical thanks to its control. An idle consumption is about 15 to 20 mA. Using an oscilloscope, we can see how the duty cycle of the pulses changes at the gate of the field effect transistor, depending on the output load. The larger the output power, the longer the operating cycle of the transistor. That is, more energy enters the choke and consequently the self-induction energy also increases. Now let's look at the design. The PWM chip is mounted on a panel. If you intend to use a converter in a car, then I advise to solder the chip directly to the board because there are always vibrations in the car. There is a great choice for field effect transistor. You can use any with a current of 20 amperes and a voltage of at least 50 volt. I just use my favorite IRFZ44, which is enough. About the power. In principle, the circuit can give 150 watts without problems, but of course this requires a more powerful transistor, for example IRF3205, and the appropriate choke. In my version, the circuit will work under a load of not more than 50 watts, although with these components it can give 100 watts. Next is a storage choke. It has inductance 40 microhenry. I just took one of the chokes of the output filter of the computer power unit. Wire diameter is 0.9 mm. The number of turns 25. But it isn't particularly critical. The inductance can differ, the size of the ring and the number of the turns too. The output rectifier is a dual Schottky diode. Can be used any with a current of 10 amperes with a reverse voltage of at least 40 volt. The circuit is protected against short circuits. It is built on the basis of a current sensor, which is a low-resistance shunt connected to the source circuit of a field effect transistor. In my case, it is a 2-watt resistor with a resistance of 0.1 ohm. After the final assembly, the transistor and rectifier are mounted on a common heatsink with properly insulation. The module is rather compact. The assembly is tight. Unlike the Chinese analog, in our version only deep components are used and in case of repair, our option has the advantage. Friends, in the description under the video you will find a link to the full archive with the circuit and PCB, as well as links to purchase components for the assembly and finished converters. If this video was useful, don't forget to rate it and share it with your friends in social networks. With you was Kasyan TV. Goodbye.